Good morning, guys. Can you hear me? Can you see it? How is it? The view of the problem. Should I rotate it? So good morning, everyone, once again from Strumitsa. My name is Hatice. I'm math teacher here. Yesterday you had complex lesson with Mr. Erdener. Today and tomorrow we will have quadratics. Before I start to solve the problems, I want to remind you some basic formulas in quadratics. Then we will start to solve problems. Can I start? Is everybody here? I can see only 12. I guess some are teachers. Strumitsa kids, I cannot see you. Please show reaction. Spase, Dimitar, Sandra, Monica. Okay, my responsible one is here. Okay, let's start. Quadratics. First of all, a quadratic equation is written in the form of ax squared bx plus c is equal to 0, where a is not 0. What happens if a is equal to 0? Then the equation turns into a linear expression, so a cannot be 0. We use some different methods to solve quadratic equations, but today I will remind you quadratic formula. Quadratic formula, to be able to solve a quadratic problem by quadratic formula, we use delta. Super, Sandra came as well. Delta or discriminant, I usually use delta. Delta is b squared minus 4ac. If delta is greater than 0, then the equation has two real roots, x1 and x2. If delta is equal to 0, then roots are equal. The equation has only one real root, x1 is equal to x2. And if delta is smaller than 0, then there is no any real root. Yesterday you have studied complex numbers. Probably the equation has imaginary roots, but it does not have a real root. And also we will use Vieta's theorem today. What says the theorem? The theorem says you do not have to solve a quadratic equation to find sum and product of the roots minus b over a. The coefficient of b, negative the coefficient of b x divided by the coefficient of x squared gives you sum of the roots, which is minus b over a, and product of the roots is c over a. These are basics of quadratics. For some quadratic problems, today I will use factorization method, because if the numbers are big, calculating square of a big number is harder. You cannot use calculators, so for some exercises, factorization method is easier, so I will use factorization method. Let's start. Let's start to solve our problems. The lesson will be like your regular Olympiad lessons, guys. I will show you the problem. You will have a couple of minutes to think about the question, to see it, to guess the method, how to solve it, to understand the question. At least to copy it down, you will have a couple of minutes, and then I will explain the solution. Problems are from last year's and this year's Sigmas, and from older regional Republican Obshtinsky questions. I will mention for each question where I chose them. Here is the first problem. Let's start. If the larger root of the equation 2003x to the power of 2 minus 2002 times 2004x minus 1 is n, and the smaller root of the equation x squared plus 2002x minus 2003 equals 0 is n, then find the difference of m and n. Yeah, you have a couple of minutes to think about the question. What are we supposed to do? While you're thinking about the question, let me see who came. Spase, is Spase here? Can you please write the schools, guys? Then I will check at the end of the lesson. Who are here from Gostivar? Who are here from Tetovo, from Struga, from Karposh? Hello, Philip. Hello, Christina. Welcome, guys. Welcome. Karposh kids. What do you think? How to solve this problem? Is quadratic formula easy for this exercise? Or can we try to factorize it? Or does it help us? No? Which one no? Buyurun hocam. Evet, buyurun hocam. Ders Evet, evet başladı, şu an dersteyiz. Tamam. By quadratic formula. Okay, sir. Good luck with the calculation then. And not with quadratic formula. Okay, sorry. Can we start to solve it? Welcome, Damian. Yep, let's start to solve the problem. Of course, it can be solved by quadratic formula, but 2003 to the power of 2 and 2002, 2004, these are really big numbers. So what to do? I will factorize the first equation. Let's see the equation here. 2003 x to the power of 2. Factors of this expression 2003 squared times x and x. These are the best ones when I check. And factors of minus 1 are 1 and minus 1. So the factorization of the quadratic expression is x minus 1 times 2003 squared x plus 1. How did I get it? Here, if you write 2003 squared x, since I multiplied it by minus, so it will be minus 2003 squared x plus x. Let me take x out of the brackets. We will get 1 minus 2003 squared. So is it difference of two squares? Yes, it is. So the sum will be x times the difference of the 1 and 2003. It will be minus 2002, and the sum will be 2004. So I got this expression, as you see, so I factorize it by this way. X minus 1 times 2003 squared x plus 1 is equal to 0, which means that x is 1, and x is minus 1 over 2003 to the power of 2. Let's go back. What did they ask me? M should be the larger root. So which is larger from those two? Of course, the positive one is larger, so m is going to be 1. For the first equation, we got m. M is equal to 1. What about the second one? Here it is. X squared minus plus 2002x minus 2003 is equal to 0. It's much easier to see the factors of this. Factors of x squared are x and x, and factors of negative 2003, positive 2003, and negative 1. If I factorize, x minus 1 times x plus 2003 are factors of this trinomial. So what will be the roots of the second equation? The roots are 1 and negative 2003. Let's go back. What did they ask me for the second one? They asked me smaller root. N has to be the smaller root. So if n is the smaller one, Let's check it, which is smaller. The negative one is smaller. N is negative 2003. And the question asks m minus n. Let's calculate it. The easiest part left. M minus n is equal to 1 minus negative 2003, which is 2004. This was an easy problem. Any question? Is there any question, guys? I will show the solution from the beginning once again. If you haven't copied or if you weren't here from the beginning. When you copy the question, when you finish writing and you got the problem, please write here done. Show it from the beginning. Okay, I will. First, here is this question. Then I have factorized the first equation. I used factorization method for this exercise. We got n. And this is for the second equation, what I did. And at the end, I found the difference of m and n. Most of you wrote done, so can we solve the next problem? Okay, let's see the next problem. Next problem is a question from Republic from 2014, 4 years ago. This problem is asked in Republic. Solve the equation in the set of real numbers. 3x plus 1 times 4x plus 1 times 6x plus 1 times 12x plus 1 is equal to 2. Again, you have a couple of minutes. First, think about the left side of the equation. Is this a quadratic equation? If not, how to reduce it to a quadratic equation? After I get a quadratic equation, that part is easy. I will solve it by quadratic or by factoring. I will solve it. But the first problem for this exercise is it is not given in quadratic form. When you multiply them all, you will get a higher degree equation. So remember, what do we do when we get higher degree equations? We usually try to reduce by using a helping variable. We reduce the equations to quadratic form. After that, we solve the question, but how to reduce it to a quadratic form? Do you have any idea? Or have you seen this problem before? Strumitsa kids, I have solved you a similar problem, not the same one. We solved a similar problem in our Olympiad lesson. We have 3x plus 1, 4x plus 1, 6x plus 1, and 12x plus 1. In this form, can we choose a helping variable like t or k or a, whatever you choose? If I assume, for example, the first one is t, how can I write in terms of t, the second factor? Can we write it? No reaction means x plus t. Can I start to solve it? Right. Guys, if they were all 12x and the constants were different, it would be much easier for choosing a helping variable. But they are not. So can I make them same? Can I get a common coefficient here? 3, 4, 6, 12. What is LCM of 3, 4, 6, and 12? It is 12, right? So can I multiply the first factor by 4? First factor by 4, and the second factor by 3, and the third factor by 2, and just copy it down, the fourth factor is equal to 2. So remember, if you multiply left side of the equation by 4, 3, and 2, you have to multiply right side as well. So 2 times 4 times 3 times 2. Let's see, what do we have now? We have 12x plus 4, 12x plus 3, 12x plus 2, and 12x plus 1 equals 48. Can you see the common terms now? 12x, 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 12x. If I assume the last one, let me start from the last one. If I assume that this is a, t, k, whatever you want, what did I choose? I chose A. If the last one is A, if we assume that 12x plus 1 is equal to A, the last one will be A, the third one will be A plus 1, the second one will be A plus 2, and the first one will be A plus 3. So the product of A plus 3, A plus 2, A plus 1, and A is equal to 48. Is this a quadratic expression? Not yet, but it's much easier to group and to reduce it to a quadratic equation. So let me group first and fourth, second and third. If I group and multiply them, I will get the equation. A squared plus 3a times a squared plus 3a plus 2 is equal to 48. Do we have common terms here? In the first factor, I have a squared and 3a. In the second factor, I have a squared, 3a plus 2. So can we say that as a squared plus 3a is equal to k, then the first factor is k, and the second factor will be k plus 2 is equal to 48. Finally, I got a quadratic expression, right? So by quadratic formula or by factorization, I will solve this quadratic equation. K squared plus 2k minus 48 is equal to 0. I used factorization. K minus 6 and k plus 8 gives me k squared plus 2k minus 48. So here we have two solutions. K is 6 and k is negative 8. Are we done? Are we done, guys? Not yet. Remember, the question solved the equation. I got k. So let's go back. What was k? K is a squared plus 3a. So the first one. If k is equal to 6, a squared plus 3a will be 6. So I will get this quadratic equation. Can you see? No. I will get a squared plus 3a minus 6. A squared minus plus 3a minus 6. When you solve it, factoring is not that easy, so we use quadratic formula. A1 and A2 are by the formula. I'm not writing all the steps. I think you know how to get it. Minus 3 plus or minus root 33 over 2 are the roots for the first case, if k is equal to 6. What is the other case? K is equal to... Oh, wait a second. I got A. Did I get X? No, not yet, so I'm not done. Let's go back. What was X? What was A in terms of X? A is equal to 12x plus 1. If A is 12x plus 1, then 12x plus 1 is minus 3 plus or minus root 33 over 2. So what are roots of this? Minus 3, if 1 comes to the other side, it will be minus 5 plus or minus root 55 over 24. I didn't write all the steps, but after a couple of steps, you will get x1 and x2. You will get two roots from the first case, negative 5 plus or minus root 55 over 24. What about the second case? The second case, k is equal to negative 8. If k is equal to negative 8, a squared plus 3a plus 8 is equal to 0. We'll get this quadratic expression. Is this quadratic equation solvable? When you check delta, delta will be smaller than 0, so there won't be any real solution for the second case. So we have only two roots. What are they? Negative 5 plus or minus root 55 over 24 are the roots of the equation. Yes, before I solve it, Philip, guess which will be t. Bravo, Philip. So let's see the solution from the beginning. What did we do? We multiplied both sides of the equation by 4, by 3, and by 2. Why did we do that? Because we tried to get a common coefficient for x. After we multiply, we got 12x plus 4, 12x plus 3, 12x plus 2, 12x plus 1. Then we assume that the last one is t. Philip said t, I said a. A plus 1, a plus 2, a plus 3 is equal to 48. Then when we group first and fourth, we got a squared plus 3a. When we group second and third, we got a squared plus 3a plus 2. Then we assume that a squared plus 3a is equal to k. If it's equal to k, then we have k times k plus 2 is 48. This is a quadratic expression. We can solve, we know how to solve a quadratic problem. I used factorization method. K squared plus 2k is negative 48. When you factorize it, k minus 6 and k plus 8, so k is 6 or negative 8. Then we check if k is 6. If k is 6, we got a, but we were not done because we were supposed to find x. What was a? A is 12x plus 1, so 12x plus 1 is negative 3 plus minus root 33 over 2. So the roots from the first case will be negative 5 plus or minus root 55 over 24. And when you check the second case, k is negative 8. The quadratic equation does not have a solution because delta is smaller than 0. Any question, guys? Is it clear? I want to show from the beginning. I think you copied, huh? Okay, let's solve another problem. Here is the new problem. Given that alpha and beta are the real roots of the equation x squared minus 2x minus 1 is 0, find the value of 5 alpha to the power of 4 plus 12 beta cubed. How to solve the problem? I think most of you are planning to solve the quadratic equation x squared minus 2x minus 1, then to find alpha and beta, then to substitute them in the expression. Or am I wrong? Do you have any other method? I'm planning to use it at the end, but how to use it at the beginning, because we have alpha to the power of 4 and beta cubed. The degree of alpha and beta are not same. Did you get the roots of the equation, alpha and beta? Did anyone get the roots? What are they, Philip? The ones who got the roots, you can substitute alpha and beta in this expression. 5 alpha to the power of 4 and 12 beta cubed. Yeah, what a nice root, right? 1 minus square root of 2 over 2. It takes time to find fourth power of that root or cube of that root, right? So let me show you my method, how I solve the question. Okay, first we said that if alpha and beta are the roots of the equation, they have to satisfy the equation, right? When I substitute alpha here in the equation, I got alpha squared is equal to 2 alpha plus 1. So alpha squared is, in terms of alpha squared is 2 alpha plus 1. And what are we asked in the expression? Alpha to the power of 4. So can I square this? Why not? So alpha to the power of 4 will be 2 alpha plus 1 squared, which is 4 alpha squared plus 4 alpha plus 1. Did I get how much alpha squared in terms of alpha? Yep. The first one is alpha squared is equal to 2 alpha plus 1. So let me substitute it here. Alpha to the power of 4 is equal to 4 times 2 alpha plus 1 plus 4 alpha, I just copied it, 1. When you multiply 4 by 2 alpha plus 1 and add it to 4 alpha plus 1, you will get alpha to the power of 4 is equal to 12 alpha plus 5. Any problem up until here? We got alpha to the power of 4 in terms of alpha, the first expression. Without the coefficient, I will multiply it by 5 at the end of the question, at the end of my solution, but that's later. And by the same method, buyurun hocam, buyurun hocam. Yok hocam, şu an çocuklar var, normal yani o kendi link paylaştığım linkteki kanaldan. Evet, şu an 15 tane de çocuk var, izliyorlar. Bu canlı yayın hocam, şu an yani 15 tane de çocuk var. Tamam. Sağ ol. Excuse me guys. Mr. Rajai was calling. So, by the same method, beta squared, when we substitute beta in the equation, we got beta squared is 2 beta plus 1. If beta squared is this, how can I find beta cubed? I will multiply beta squared by beta. When I do that, I will get 2 beta squared plus beta. We know what beta squared is. We will substitute it here. And we get beta cubed is 2 times 2 beta plus 1 plus beta, which means that beta cubed is 5 beta plus 2. Opa. Is it clear? Is there any question up to here, guys? So, at the end, what do? We were asked 5 alpha to the power of 4 plus 12 beta cubed. So, I will substitute alpha to the power of 4, what I got here. I will substitute in the expression 5 times 12 alpha plus 5 and 12 times beta cubed, which is 5 beta plus 2. When you simplify this expression, you will get 60 times alpha plus beta and 49. How can I find the sum of alpha and beta? How can I find sum of the roots of the quadratic equation x squared minus 2x minus 1? Now in this step we need beta. We know minus b over a gives us the sum of the roots. So alpha plus beta is going to be minus negative 2 divided by 1, which is 2. So if alpha and beta is 2, when we substitute here in the expression 60 times 2 plus 49, 5 alpha to the power of 4 plus 12 beta cubed will be 169. Is there any question, guys? Is it clear? I will show the solution from the beginning. Here is the question. Here is the question. How did I solve the problem? From where is the question? The question is from an Olympiad book, but I do not remember from which one. But I'm sure this is not from Sigma's. It's from an Olympiad book. Why didn't you like it? Here is the first part and here is the second part. Let me check once again. Strumitsa kids. Dimitar and Spasi, I cannot see you. Are you here? Can Monica or Sandra call them, please? Thank you, Mr. Rajai. Guys, can I give the new problem? Is there any unclear step? If you want, I can go back once again. We could solve this problem by finding roots alpha and beta, but since we'll get really nice roots, we didn't do that method. We didn't solve it by that way. I substitute alpha in the equation. I got alpha squared is, alpha to the power of 4. After a couple of steps, I got alpha to the power of 4 is 12 alpha plus 5, and beta cubed is 5 beta plus 2. Then we substitute them in the equation. We got 60 times alpha plus beta is 49. And we know the sum of the roots from the equation, from the theorem. 60 times 2 plus 49 gives us 169. 169 is the sum of 5 alpha to the power of 4 and 12 beta cubed. I think it's enough for this question. Here is another problem. Solve the equation x squared minus 8 times x plus 1 squared plus x squared is equal to 0. This is from Regional, from 2014. An equation is given. We are supposed to solve it. But is this a quadratic equation? When you simplify, when you multiply x squared minus 8 by x plus 1 squared and add it to x squared, do you get a quadratic? What do you think? How to solve this problem? Somehow we have to reduce it to a quadratic expression, but how to do that? It's nice, the right side of the equation is 0, so we can divide the whole equation by something, but what should be that thing? By what are we supposed to divide both sides? I want you to try to solve this problem a little bit. You will have extra time for this question. Original one. Can we use a helping variable in this step, guys? Like x plus 1 is t, or x squared minus 8 is t. Can a helping variable help me in this step, in this form? No comment means solve the question or? No reaction, so I start to solve the problem then. Okay, before I show you the solution, let's check. X squared minus 8 times x plus 1 to the power of 2 plus x squared. As you see, a helping variable cannot help me when the equation is in this form. So I will try to change it a little bit. How can I change it? I will try to reduce it to a quadratic expression. So as I see, the first term of the expression is a little bit complicated. Let's make it simpler then. Can I divide the whole equation by x plus 1 or by x plus 1 to the power of 2? Can I do that? Why not? But to be able to divide the equation by x plus 1 to the power of 2, I have to check whether minus 1 is a root of the equation or not. So if I check minus 1, minus 1, minus 7, does it satisfy the equation? No, it does not satisfy. Demek minus 1 is not a solution of the problem. So we can divide both sides of the equation by x plus 1 to the power of 2. When I divide both sides of the equation by x plus 1 to the power of 2, I will get the equation x squared minus 8. The first term is simpler now. Plus x squared over x plus 1 to the power of 2 is equal to 0. I get a trinomial again on the left side. But it looks better because I have two perfect squares. You see, I have square of x and I have square of x over x plus 1. Is it perfect square of x plus or minus x over x plus 1? It is not, but I will try to write it in terms of x minus x over x plus 1 squared. So because I have x squared and x squared over x plus 1 squared, I have written it in this form. X minus x over x plus 1 to the power of 2. Do we have a minus 2x squared over x plus 1 in this expression? No, so I add it. 2 times x squared over x plus 1 minus 8 is equal to 0. When we write perfect square of x minus x over x plus 1, we have to add this expression because we do not have it in the previous step. And I copied minus 8 is equal to 0. Now let me simplify it. One more step we have. If I simplify the first one, I will get x squared over x plus 1 to the power of 2 plus 2 times x squared over x plus 1 minus 8 is 0. Now, does this look like a perfect square? Let's see, does this look like a quadratic expression? Yes, it does. I can use helping variable here. I have perfect square of x squared over x plus 1 times 2 times x squared over x plus 1 minus 8. So we can say x squared over x plus 1 is equal to u. This time I chose u. U squared plus 2u minus 8. I think all you can see the factors of this quadratic. U minus 2 and u plus 4 are the factors of this quadratic expression. So the roots are 2 and negative 4. If u is 2, then we go back. If u is 2, x squared over x plus 1 is 2. Write the quadratic equation. When you solve it, you will get 1 plus or minus root 3. Here I just applied quadratic formula. After simplifying, I got 1 plus or minus root 3. And if u is minus 4, here we get x squared over x plus 1 is minus 4. And the quadratic equation is x squared plus 4x plus 4 is 0, which is perfect square of x plus 2. So x3 is equal to the third root is negative 2. So how many solutions do we have for this problem? From the first case, if u is 2, we have two solutions. 1 plus or minus root 3. And if u is equal to minus 4, we have only one solution, which is minus 2. So in the solution set, we have 3 roots. Any question? Any question? I will show the solution from the beginning. The equation was given in this form. We checked x equals minus 1. It is not a root of the equation, so we divided both sides of the equation by x plus 1 squared. Then we tried to get a quadratic equation. We got x squared over x plus 1 to the power of 2, and 2 times x squared over x plus 1 minus 8 is equal to 0. In this form, this is not a quadratic. It is a 4-degree equation, but if we reduce it to a quadratic by assuming x squared over x plus 1 is equal to u squared plus 2u minus 8 is equal to 0 is a quadratic equation. And the solutions of this quadratic problem are 2 and minus 4. Then we check it for 2 and minus 4. If x squared over x plus 1 is 2, the roots are 1 plus minus root 3, and if u is equal to negative 4, the root is negative 2. So we have 3 roots for this problem. Any question, guys? Did you get the problem? Did you understand it? Christina? So I can change it, right? Let's do next problem. Irrational expression. My students in Strumitsa, they love this type of expressions. They love cube roots, nth root of a number, and equations with them. I hope you like them as well. Cube root of 2 plus root 5 plus cube root of 2 minus root 5 is equal to 1. Prove it. While you are thinking about the question, I'll take a break. Yep, how to solve the problem? How to prove that is the radical expression is equal to 1. Cube root of 2 plus root 5. When you check the radicands are conjugates, right? 2 plus root 5, 2 minus root 5. By the way, while you're trying to solve the problem, I can remind here a plus b cubed. Cube of a plus b is a cubed plus 3a squared b plus 3ab squared plus b cubed. And there is one more form to write it. If it's helpful, you can write it in this form: a cubed plus b cubed plus second and third terms, they have common factors. Let's write it like 3ab times a plus b. This is the form that I will use to solve this problem. If I have written this formula, probably we will cube both sides of the equation, or first we will cube the left hand side of the equation and prove that it is equal to 1, right? Let's see. First of all, I chose the left hand side of the equation. I will work on the left side and prove that it is equal to 1. Then the proof will be done. If the left side is equal to right side, the proof will be done. Assume that x is equal to cube root of 2 plus root 5 and cube root of 2 minus root 5. Then I'm going to cube it. I will cube x. If I cube it, cube root of 2 plus root 5 cube will be 2 plus root 5. And cube of this will be again 2 minus root 5. Then you see I'm using this form. Plus 3 times a times b. First a plus b I have written. Okay, a plus b, which is x. I just copy it down, which is x, times the product of first and second terms. Cube root of, in brackets, 2 minus root 5, 2 plus root 5. It is not that clear. If you want, I can write it once again here. Here we have 2 minus root 5, 2 plus root 5. So is it difference of 2, sum and difference of two expressions? So can I write it in this form? 2 squared minus root 5 squared? Yes, I can. So let's simplify. What do we have here? X cube, x cube is 2 positive root 5 negative root 5 divided them. 2 plus 2 plus 3 times sum of a and b, sum of these two, isn't it x? So let's substitute here x times, what will be 2 squared minus root 5 squared? Is it going to be cube root of minus 1, guys? Yes, it is. And cube root of minus 1 times x times 3. We know that cube of minus 1 is minus 1. So minus 1 times x times 3 will be minus 3x. And from 2 and 2 we got 4. So x cube is equal to 4 minus 3x. The 6 we have. How many? X times. So x times x will be x to the power of 2, and x times minus 1 is minus x. Again, we subtract them. X squared minus x squared will be 0. 3x minus negative x will be 4x minus 1. So 4x minus 1, x minus 1. How many x minus 1 do we have in 4x minus 1? We have 4. So the quotient will be x to the power of 2. X to the power of 2 plus x plus 4. Guys, do we have any connection problem? Can you hear me? No problem, right? Okay. X squared plus x plus 4 is the quotient. So how do we write the cubic expression? X cubed plus 3x minus 4 is equal to x minus 1 times x squared plus x plus 4. Okay. Look at this. Cubic equation is 0. So If this expression is equal to 0, there are two cases. X minus 1 is equal to 0 or x squared plus x plus 4 is equal to 0. When we check the first factor, x minus 1 is equal to 0, then x is equal to 1. If we check the second factor, x squared plus x plus 4 is equal to 0. When I check delta, it will be smaller than 0, which means that there is no any real root. So there is only one solution for this problem. X is equal to 1. Let's go back. What was x? X is the left side of the equation. So for the left side of the equation, there is only one solution, which is 1. Means that if the only solution is 1, this expression, which is x, is equal to 1. And the proof is done. Any question? How was this problem? Did you like it? Did you get it? Let me show from the beginning. Prove that cube root of 2 plus root 5 and cube root of 2 minus root 5 is 1. We use this identity to solve the problem. We assume the left side of the equation is x. Then we cube x. When we cube the left side of the equation, we got 4 minus 3x. We got this cubic equation. X cubed is equal to 4 minus 3x. When you simplify everything here, you will get x cubed equals 4 minus 3x. And then we have to solve this cubic equation. To be able to solve it, we need to factorize. How did I factorize? I've checked the coefficients. I have seen that 1 is satisfying the equation. If 1 satisfies the equation, then x minus 1 has to be a factor of this. If x minus 1 is a factor, when I divide the polynomial, when I divide this cubic expression, cubic equation by x minus 1, I will get a quadratic. Then it will be easier to solve the problem. So by polynomial division, we divided x cubed plus 3x minus 4 by x minus 1. We got x squared plus x plus 4. Then if x cubed plus 3x minus 4, if the cubic equation can be factorized as x minus 1 times x squared plus x plus 4, then x minus 1 is 0 or x squared plus x plus 4 is 0. If the first one is 0, then x is 1. If the second one is 0, there is no any real root because delta is smaller than 0. So there is only one solution for this problem. X is equal to 1. Then what was x? X is left hand side of the equation. We proved that cube root of 2 plus root 5 and cube root of 2 minus root 5 is equal to 1. Any problem, guys? Up until here, any problem? We have solved 5 problems. Am I fast or slow? Please write me if there is any problem. Okay, I think this is enough. Let's see the next problem. 2 years ago from Opshtinsky. Find the integer solutions of x squared plus bx plus q is equal to 0 if p plus q is 2017. This is an easy one. If they ask us to find the integer solutions of a problem, excuse me, I couldn't read it. How is it now, Christina? Is it better now? Same. Do all you have the same problem? Okay. Find the integer solutions of the quadratic equation if p plus q is equal to 2017. Finding integer solutions, these type of problems are a little bit easier because if you're asked to solve a problem in the set of real numbers, you have many cases. For example, if you're asked to solve a times b is equal to 10. If you're asked to solve this problem in the set of real numbers, there are many solutions, right? A and b. A can be any real number. When you multiply by b gives you 10. For example, can a be, if you're supposed to solve it in the set of real numbers, can a be, let's say, 3 over 4? Can it be? Yes, it can be. 3 over 4 times what gives you 10? 3 over 4 times what gives you 10? You can solve it by cross multiplication. 40 over 3. Are both real numbers? Yes, they are. Is it possible to check all possibilities, all real numbers? No, it is not. But if you are supposed to solve this problem in the set of integers, or it's much easier in the set of natural numbers, a times b is 10. So what are integer factors of 10? We know that 1 times 10 gives us 10, or 2 times 5 gives us 10. If you are solving this problem in the set of integers, you also have to check positive and negative numbers. So we can write that factors of 10 are positive negative 1, positive negative 10, positive negative 2, positive negative 5. If you're supposed to solve the problem in the set of natural numbers, you do not even check the negative ones, so you will have only 4 roots. In the set of natural numbers, you have 4 roots. In the set of integers, you have 8 roots, 8 possibilities. And if you have to solve the problem in the set of real numbers, this is only one case, the one I have written. There are infinitely many solutions for this problem. So if you're supposed to find the integer solutions of this, it's a little bit easier than the previous exercises. How to solve it, how to start. P and Q, the sum of P and Q. Does Vieta help us here? What do you think? Okay, I gave the hint, so can you please try to find sum of the roots and product of the roots by Vieta? Bravo, bravo Christina. I think you have started solving problem. Sum of the roots, as we see, sum of the roots of the equation minus b over a, which is minus p, and product of the roots is q. How to write p plus q then in terms of x1 and x2? In terms of roots of the equation, how can we write this sum p and q? We can write it as p plus q is minus, because here we have minus p, negative x1 plus x2 and x1 times x2, and after that, as Christina said, x1 minus 1. This expression can be factorized as x1 minus 1 times x2 minus 1. When I write it in this form, I had a positive 1, but I do not have it in this expression, so I have to subtract 1. So when I factorize this, I will get x1 minus 1 times x2 minus 1 minus 1. And let's remember what was p plus q, guys. If p plus q is 2017, then the product of x1 minus 1 and x2 minus 1 is going to be 2018. Since I'm supposed to solve the problem in the set of integers, I'm supposed to check the integer factors of 2018. 2018 integer factors, 1 times 2018 gives me 2018. So I have written positive negative 1, positive negative 2018. And when I divide it by 2, 2 times 1009 and negative 2 times negative 1009 gives us, since 1009 is a prime number, we do not have any other factor for 2018. So how many possibilities do we have for x1 minus 1 or for x2 minus 1? 1 and minus 1, 2 and minus 2, 1009 minus 1009, 2018 and negative 2018. Not to write a lot of steps, not to write all of the cases. Let's assume that the first root is smaller than the second root. If first root is smaller than the second root, then we have these cases. First case, if x1 minus 1 is equal to 1, x2 minus 1 is equal to 2018, which means that x1 is 2 and x2 is 2019. These are the solutions from the first case. From the second case, x1 minus 1 is minus 1 and x2 minus 1 is minus 2018. So here in this case, x1 is going to be 0 and x2 is going to be negative 2017. From the third case, x1 minus 1 is 2 and x2 minus 1 is 1009. So x1 is going to be 3 x2 is going to be 1010. From the fourth case, x1 minus 1 is negative 2, x2 minus 1 is negative 1009, so x1 is negative 1008. Yep, I hope the question is clear. What did I do? I used Vita. The theorem says sum of the roots is negative p, product of the roots is q. Then I have written p plus q. P plus q in terms of x1 and x2 minus x1 plus x2 plus x1 times x2 can be factorized as x1 minus 1, x2 minus 1, but we have to subtract 1. From here we'll get x1 minus 1 times x2 minus 1 is equal to 2018. 2018 integer factors of 2018 are 1, negative 1, 2, negative 2009, negative 1009, and 2018 and 2000 negative 2018. If I assume that the first root is smaller than the second root, the absolute value of first root is smaller than the absolute value of second root, we will have four cases. x1 is x2 is 2019, or x1 is 0, x2 is negative 2017, or x1 is 3, x2 is 1010, and the fourth case, x1 is negative 1 and x2 is negative 1008. Any problem, any question, guys? Is it clear? Should I wait more? Or can I show you a new problem? New problem. Super. Let's see the new problem. Given that a is a root of the equation x squared minus x minus 3 is equal to 0, then evaluate a cube plus 1 over a5 minus a4 minus a cube plus a squared. I think this is a nice question as well. It is similar to the problem with alpha and beta. Given that a is a root of the equation, which means that a has to satisfy the equation x squared minus x minus 3, I want you to simplify a cube plus 1 over a to the power of 5 minus a to the power of 4 minus a cubed plus a squared. The long way of solving this problem, finding roots of the equation, then to substitute it in given expression. Or you can use the method that I solved the problem with alpha and beta. If a is a root of the equation, then it has to satisfy this, which means that a squared minus a minus 3 is equal to 0, and so on. Try to solve it a little bit, then I will start to explain the question, the solution. Are you solving? What did you get? Are you solving the equation x squared minus x minus 3? Then to substitute the roots. Let me give you the hint, guys. Please factorize a cubed plus 1 and factorize a to the power of 5 minus a to the power of 4 minus a cubed plus a squared. You will write numerator and denominator in terms of a. Then you will be able to find the ratio, and it gives you the solution of the problem. Try to factorize it. A cubed separately, a cubed plus 1, and bravo, Christina. It is 4 over 9. Anyone else? Okay, let's see the solution then. X squared minus x minus 3 is equal to 0. And a is a root of the equation. We need to calculate a cubed 1 over a to the power of 5 minus a to the power of 4 minus a cubed plus a squared. While I'm solving this problem, I will use, also Philip solved it. Bravo, Philip. How did I solve the problem with alpha and beta? I substitute the root of the equation in this quadratic equation. A squared is 3 minus a, or if we write it in its simplest form, a squared minus a is equal to 3. So a cubed plus 1. How can I factorize this? A cubed plus 1 is a plus 1 times a squared minus, here it was supposed to be a minus a squared, a plus 1 times a squared minus a plus 1. So we know from the first expression, we know that a squared minus a is equal to 3. And when I substitute it, it will be 3 plus 1, 4. A cubed plus 1 is 4 times a plus 1. And by the same way, if I factorize a to 5 minus a to 4 minus a cubed plus a squared, all the expressions are divisible, all the terms are divisible by a to the power of 2, so it's out of the brackets. A squared times a cubed minus a squared minus a plus 1. And then here I can group first and second, a squared times a minus 1 minus a minus 1. I just changed the signs, be careful, minus a minus 1. So if I factorize this, I will get a squared times a minus 1 times a squared minus 1. A squared minus 1, what's this, guys? A squared minus 1 is difference of two squares, so I can factorize it like a minus 1 times a plus 1. So I will have square of a minus 1 and 1a plus 1. A squared times a minus 1 to the power of 2 times a plus 1. What do you see here? A squared and a minus 1 squared. What do you see here, guys? Is this a squared minus a to the power of 2? A squared minus a to the power of 2. Yes, it is. And if it is a squared minus a to the power of 2, that means it is 3 to the power of 2. You see, we have 9 times a plus 1. When I write both numerator and denominator in terms of a, I got this. A cubed plus 1 is 4 times a plus 1. And the denominator is equal to 9 times a plus 1. we are asked the ratio, so a plus 1 and a plus 1. Digrik 4/9 is the simplest form. 4/9 is the solution. Let me show you the solution from the beginning once again. Any problem, guys? Hüseyin and Philip, they already solved the problem. I'm asking to the others. Any question? Is it clear? We solved a similar problem, so we used the same method. We substitute a in the equation and we got a squared minus a is equal to 3. We're going to use this form. We use this form for numerator and denominator. A cubed plus 1 is a plus 1 times a squared minus a plus 1. Here I have a squared minus a. When I substitute, it's 4 times a plus 1. When I do all these factorization steps, I got the denominator is equal to 9 times a plus 1. And when you find the ratio 4 times a plus 1 over 9 times a plus 1, that's equal to 4/9. Here is the end of the problem. I think this is enough for this exercise. Let's see the next problem. Next problem is a nice one. Prove that if a and b are the roots of the equation x squared plus px plus 1 is 0, and c and d are the roots of the second equation, which is x squared plus qx plus 1 is equal to 0, then a minus c times b minus c times a plus d times b plus d is equal to q squared minus p squared. Guys, I want to listen to you for this problem. Can you please try to guess what to do first? We are supposed to prove that this expression is true. Yes, Vieta. Mr. Vieta will help us. We can find sum and product of the roots. We can find sum of a and b, product of a and b, sum of c and d, product of c and d. And then substitute them on the left side of the equation, and we will try to get q squared minus p squared on the left side. Can all you please find sum and product of the roots by the theorem? A plus b, a times b, c plus d, c times d. Yeah, for both, the product is 1. What about the sum of the roots? A and B, C and D, what are they? Yes, negative P and negative Q are sum of the roots respectively. A and B is negative P, C and D is negative Q. Now how can I use this x1 times, A times B, A plus B, C times D and C plus D in this expression, in this equation. The left side of the equation, if we multiply them all, how to multiply? I think we have to group them, right? We have to group them first. How to group them? When I group them, I have to be careful because, for example, if I group first and second, third and fourth, I will get A and B, also C squared. Do we know what C squared is in terms of sum and product of the roots? No, we do not know. So better to choose A minus C by B plus D. I mean, first by the fourth one and first by the fourth one and second by the third one. What happens when I group them like this? I will get A times B, I will get C times D, and I will be able to simplify A, B, and C, D. Let's see. First, I have written here what I have from the theorem. A plus B is minus P. A times B is 1, C plus D is negative Q, and C times D is 1. And when I group them, like first and the fourth, second and the third, we will get this. When I multiply AB plus AD minus BC minus CD times BA, can you see it? Yeah. BA plus BD minus AC minus CD. From the theorem, we know that AB is 1 and CD is 1. So here we have 1 and minus 1, which means I can deduct them. Here we have again A, B, C, D, 1 and minus 1, we deduct them. So what left? This product is equal to AD minus BC times BD minus AC. So let me multiply them once again. If I multiply first by the first, it's ABD squared. First by the second, it's minus A squared CD. Second by the first, minus B squared CD. Second by the second, positive ABC squared. So do we have in these terms, in this expression, do we have A times B and C times D? Yes, we do. Let's substitute them. Here AB is 1. Here CD is 1. Here CD is 1 and AB is 1. So is the expression turns into D squared, because AB is 1, D squared minus A squared minus B squared plus C squared? Yes, it is. Now, D squared and C squared, A squared and B squared. I will try to write this expression in terms of A plus B and C plus D, because on the right hand side we have Q squared and P squared, which means that I'm sorry guys. I'm supposed to write the left side of the equation in terms of sum of the roots, which are P and Q. Here A plus B is minus P, C plus D is minus Q. How can I write it in that form? Let me group first and fourth, second and third. How do we write it? If I group first and fourth, can I write D squared and C squared in this form? D plus C squared minus 2CD? Yes, we can. And here I have the second and third terms. Minus A squared minus B squared. Can I take minus out of the brackets and write it as A squared plus B squared? And can A squared plus B squared be written in this form? A plus B to the power of 2 minus 2 times A times B. Yes, it can be written in this form. So D plus C. I have it. I know what D plus C is. It is negative Q. And A plus B, I know it. It is negative P. So let me substitute them. The first one, D plus C squared, which is Q squared minus 2. Why minus 2? Because c times d is 1, so it will be minus 2. Minus a plus b to the power of 2, which is p squared. P squared minus 2 times a times b, which is 2. So we have q squared minus 2 minus p squared minus 2. If I simplify this expression, when you multiply the second one by minus 1, you will get q squared minus p squared minus 2 plus 2, which is equal to only q squared minus p squared. I hope it is clear. I think this is a nice question, guys. I hope you liked it. Is there any question about this exercise? Is it clear? Clear. Nice. Okay, guys, if you got this problem, we have a break now. 1 hour and 40 minutes first lesson. Next lesson will start at 11. See you in 20 minutes. See you in 20 minutes, guys.